Flow diagrams are a visual representation of processes or algorithms used extensively in computing to depict the flow of control and the sequence of actions within a system. They employ a set of standardized symbols, each representing a specific type of command or operation. These symbols are connected by arrows that indicate the direction of flow, guiding the reader through the logical progression of the process. The use of different shapes ensures clarity, making it easier to distinguish between various components of the algorithm. One common shape in flow diagrams is the rectangle, which represents a process or action that must be performed. For instance, a box labeled Calculate Total might indicate a step where numerical values are summed. Another frequently used shape is the diamond, which signifies a decision point. At this stage, a question is posed such as, is the value greater than 10? The answer to this question determines the subsequent path, with arrows branching off to indicate the outcomes. The oval or ellipse is typically used to represent the start or end of a process, clearly marking the boundaries of the flow diagram. Algorithms, the step-by-step instructions used to solve problems, can be effectively illustrated using flow diagrams. By visually organizing the sequence of operations and decisions, flow diagrams make algorithms easier to understand and communicate. For example, an algorithm to determine whether a number is odd or even could be represented as a flow diagram. It might begin with an oval labeled Start, followed by a rectangle stating Input Number. A diamond would then ask, is the number divisible by 2? Arrows would lead from the diamond to two different paths, one ending in an oval marked Output Even, and the other leading to Output Odd. Flow diagrams are particularly useful in computing because they provide a clear and structured way to plan and debug algorithms. They allow programmers and problem solvers to visualize the logic of a system, identify potential bottlenecks or errors, and ensure that all paths through the process are accounted for. Moreover, flow diagrams serve as an excellent bridge between the conceptual design of an algorithm and its implementation in code. By breaking down the algorithm into manageable steps and representing them visually, they help translate abstract ideas into concrete actions. In the context of teaching and learning, flow diagrams are invaluable tools for explaining the principles of computational thinking. They encourage logical reasoning, attention to detail, and systematic problem-solving, skills that are essential in the digital age. Whether used to map out a simple process or to model complex systems, flow diagrams are a powerful means of visual communication, transforming intricate algorithms into intuitive and accessible representations.